and welcome to Shree Learning Academy. Today's focus is on encryption. And just a reminder, if you would like one-on-one training, we offer private sessions. Connect with us on WhatsApp. Now let's jump right in. What is encryption? Encryption is like putting your data in a safe box before sending it out to the world. It scrambles your information into a format that only someone with the right key can unscramble and read. Imagine you have a secret message you want to send to your friend, but you don't want anyone else to understand it. You put your message inside a special box and lock it with a unique key. Your friend has the matching key to unlock the box and read the message. And that's how encryption works. But in the digital realm, basically encryption is a process of converting readable text into ciphertext. That is also known as scrambled data. Encryption can be applied at different levels depending on what needs to be protected. Here are some common levels. Full disk encryption. Think of your computer's hard drive as a big storage box connecting all your files and data. Full disk encryption secures this entire box, ensuring that even if someone steals your computer, they can't access your files without the encryption key. It's like putting a lock on the entire storage box rather than on individual items inside. Example, when you enable full disk encryption on your computer, such as BitLocker on Windows or FileVault on macOS, all the data on it becomes inaccessible without the correct decryption key typically tied to your password. Partition encryption. Sometimes you might want to divide your storage box into smaller sections like different compartments in a drawer. Partition encryption secures each of these compartments separately. Now this means even if someone gains access to one partition, they still can't access the others without the right key. Example, you have a computer with two partitions, one for personal files and another for work-related documents. Encrypting each partition separately ensures that your personal and work data remain private from each other. File encryption. Imagine your files as individual documents stored inside your storage box. File encryption locks each document individually, so even if someone gains access to your storage box, they can only read the files they have the key for. For example, you have a sensitive document containing financial information. Encrypting this file ensures that only authorized individuals with the decryption key can access its contents. Volume encryption. Volumes are logical storage units within a disk or partition. Volume encryption protects these volumes, providing an additional layer of security for your data. For example, you have a USB drive where you store important documents. Encrypting the entire volume of the USB drive ensures that even if you lose it, your data remains safe for unauthorized access. Database encryption. Databases store large amount of structured data like filing cabinet filled with neatly organized folders. Database encryption secures the contents of these folders, making it unreadable to anyone without the decryption key. For example, a healthcare organization stores patients' records in a database. Encrypting the database ensures that sensitive patient information remains confidential, even if there is a security breach. Record encryption. Within a database, individual records contain specific pieces of information like entries in a ledger. Record encryption protects each of these entries separately, adding an extra layer of security to the sensitive data. For example, in a banking database, each customer's transaction history is stored as a record. Encrypting these records ensures that even if someone gains unauthorized access to the database, they can't view the transaction details without the decryption key. Transport encryption, that is protecting the data in transit. Imagine you are sending a secret message to your friend through a courier service. You write your message on a piece of paper, put it in an envelope and seal it with a special lock. Now you are worried that someone might try to open the envelope and read your message while it's on its way to your friend. Now that's where transport encryption comes in it. It's like putting your message in an envelope that only you and your friend can unlock. What is transport encryption? It is also known as communication encryption. It is a method of securing data as it travels from one place to another over a network. Just like the envelope protects your message from prying eyes, transport encryption ensures that no one can intercept and understand the information you are sending over the internet or any other network. How does transport encryption work? Let's break it down into simple steps. First, encryption. Before your message leaves your device, it gets scrambled into a format that's impossible to read without the right key. This process is called encryption. It's like turning your message into a secret code that only you and your friend can understand. Transmission. Once your message is encrypted, it's sent over the network to your friend's device, and during this journey, The encrypted data travels through various routers, servers, and other network devices. Decryption. When your friend's device receives the encrypted message, it uses a special key to unscramble the data and turn it back into its original form. This process is called decryption, and it's like your friend unlocking the envelope to read your message. Examples of transport encryption, that is HTTPS, Hypertext Transfer Protocol Secure. When you visit a secure website such as an online shopping site or your bank's website, you will often see a padlock icon in the address bar. This means the website is using HTTPS, which encrypts the data exchange between your browser and the website server. So when you enter your login credentials or credit card information, it's protected from eavesdropper. Virtual private network. A VPN creates a secure encrypted connection between your device and a remote server. This means that when you browse the internet or access online services through a VPN, your data is encrypted before it leaves your device and remains encrypted as it travels through the VPN server. This protects your online privacy and prevents others from monitoring your internet activity. Secure email communication. Some email services offer end-to-end encryption, which means that your emails are encrypted on your device before being sent to the recipient's device and when they are decrypted. This ensures that only you and the recipient can read the contents of the email even if it's intercepted during the transit. Instant messaging apps. Many messaging apps such as WhatsApp and Signal use encryption to protect the messages you send and receive. This means that your conversations are private and secure, and even if they pass through multiple servers before reaching the intended recipient. So how encryption works? At its core, encryption relies on complex mathematical algorithms to scramble the data into an unreadable format. The encryption process involves two main components, an encryption algorithm and an encryption key. Now, encryption algorithm. This is a set of rules and procedures used to scramble the data. There are various encryption algorithms available, each with its strengths and weakness. Common algorithms include AES, that is Advanced Encryption Standard, RSA, and DES, that is Data Encryption Standard. Encryption key. The encryption key is a piece of information used to encrypt and decrypt the data. It acts like a digital lock and key, and where the encryption key locks the data and the decryption key unlocks it, without the right key, it's nearly impossible to decrypt the encrypted data. Types of encryption keys. Encryption keys can be categorized into two types, symmetric and asymmetric. Symmetric encryption. It uses the same key to both encrypt and decrypt a message. Think of it like a lock and key. You lock the message with one key and the same key is used to unlock it. Example, imagine you have a treasure chest, that is your message, and you have a special key, that is the encryption key. You use this key to lock the chest, and when your friend receives a locked chest, they use the same key to unlock it and see the treasure inside, that is decrypt the message. Asymmetric encryption, on the other hand, uses two different keys, that is one for encryption and another for decryption. These keys are mathematically related but different. One key is public and anyone can use it to encrypt a message, but only the holder of the other private key can decrypt it. Example, think of a mailbox where anyone can drop a letter, that is encrypt, but only the owner with the private key can open it, that is decrypt. Popular algorithms. Algorithms are mathematical processes used to encrypt and decrypt the messages. Here are some popular ones. DES, that is Data Encryption Standard. It was one of the earliest encryption standards developed in the 1970s. It uses a symmetric key algorithm, meaning the same key is used for both encryption and decryption. However, due to the advances in technology, DES is now considered relatively insecure for modern application. AES, that is Advanced Encryption Standard. AES is widely used symmetric encryption algorithm today. It's much more secure than DES and is used in various applications like securing Wi-Fi networks, encrypting files, and protecting sensitive data. AES support keys length of 128, 192 or 256 bits with longer keys providing stronger encryption. RSA, that is Reverse-Shamir Edelman. RSA is an asymmetric encryption algorithm named after its inventor, and it's widely used for securing communications over the internet such as HTTPS connections for secure browsing and email encryption. RSA involves generating a public-private key pair with the public key used for encryption and the private key used for decryption. Key length. It refers to the size of the encryption key used in the encryption algorithm. In general, longer keys provide stronger encryption and are more resistant to brute force attacks, where an attacker tries all possible keys to decrypt the message. For example, AES support key lengths of 128, 192 or 256 bits. A 256-bit key is much harder to crack than 128-bit key because there are exponentially more possible combinations. For example, imagine trying to guess the combination to a lock. If the lock has only 3 digits, there are only 1000 possible combinations from 000 to 999. But if the lock has 6 digits, there are 1 million possible combinations, making it much harder to guess the correct one. So in conclusion, encryption plays a vital role in safeguarding our digital lives, whether it's protecting the personal information stored on our devices or securing the sensitive data transmitted over the internet. By understanding the basics of encryption and its various levels, we can take proactive steps to ensure the privacy and security of our data in an increasingly interconnected world. From full disk encryption to transport encryption, each level adds another layer of protection, making it more difficult for unauthorized individuals to access our sensitive information. As technology continues to evolve, encryption will remain a cornerstone of cybersecurity, providing a secure foundation for our digital interactions. Thank you so much for watching this video. And if you are looking for more personalized training, contact us on WhatsApp. We offer a range of theoretical and practical courses starting at just $99. You can also find a written explanation and a quiz on our website. Link in the description below. And don't forget to subscribe for more useful videos and feel free to ask any questions in the comments. We are here to help. See you in the next one.